guys, welcome back to another opportunity to practice our favorite F word. Yes, factor. Okay, so believe it or not, we are only gonna do 2 factoring problems, hence the spicy edition. All right, cool. So we are gonna factor these spicy problems by substitution. Okay, you're definitely gonna see this problem on the test. So if you have not been watching all the videos, I hope this is not one that you've skipped. Okay, so let's do this. So we are asked to factor completely. I'm going to show you 2 ways to factor. One is the keep your cool way, meaning do it however you can, and the other one is new way of factor by substitution. Okay, so I typed up the solution because I don't want to do it like this. So if you were to just expand all factors, then this is what you would do. Okay, so you have your binomial. Let me go ahead, zoom in, and then you do what you gotta do. So in this case, we would square the n minus 5. Okay, and then we'll distribute the 4. We'll distribute the negative 4. So pretty much clear all grouping symbols, combine like terms as you see fit. And if by some miracle you didn't make like an arithmetic mistake, then that trinomial should be factorable, and then you'll get that. Okay, so I just box it later for special effects. I myself don't do these types of problems like this because the worst thing I can do to myself is like mess up on the negative, and if I have like a mistake, then I'm not gonna get a trinomial that's factorable. And it will probably take, with numbers like this, it will probably take me a while to realize that, oh man, it's not factorable. Okay, so let's go ahead and do this. Okay, so again, my normal reaction is to clear our grouping symbols because that's how we're trained to think. Okay, and that's fine. But I want to point out that we have a binomial of n minus 5, and then check it out. Yeah, you can't see that. And then we have another binomial of n minus 5. So why don't we go ahead and do a little substitution. Okay, so let me speak to myself. Use substitution. So we're going to say let whatever variable we like represent that binomial that we see recycled. Okay, you can use any variable of your liking for this problem, anything except for the one you see on board, which is m. Okay, so I'm going to use u. Whenever I do something by substitution, I like to use u because you don't see it that often in the expression. So again, the more that I do things the same, the more that it will click. Okay, so what are we gonna do? We're gonna replace all the n minus 5s with the variable u. Okay, so we have a n minus 5. Let's go ahead and swap that out for u. What was going on with the n minus 5? Okay, it was being squared, so I guess we got to square our u. And then what else? It was being multiplied by 4. Okay, 1 substitution down, 1 more to go. So we have another n minus 5. Let's go ahead and substitute it with u. What was going on with that u? It was being multiplied by 4 and then subtracted from the first part of this puzzle, and then no more substitutions. Cool. So now at this point, yeah, that's a 15, sorry. Okay, so at this point we are going to focus our energy on this new trinomial, and then just take a pause right there. So prerequisite step when it comes to factoring is to watch out for common factors. So I'm going to ask myself, do these terms have a common factor other than 1? And the answer is no. Trinomial, is the leading coefficient 1? It is not. Because the leading coefficient is not 1, then we're going to use, I was going to say something else. Then we're going to go ahead and use the AC method. Okay, so let's go ahead and do our X game. I'll do it on the side because I'm trying to put as many problems as I can in one single column. Okay, corresponding X game, we want factors of AC that add up to B. Oh, I forgot I spread this unit in different videos. Okay, so because the leading coefficient is not 1, we're going to go ahead and use the AC method to factor. So let's go ahead and do our corresponding X game. We want factors of AC that add up to B. A is the leading coefficient, B is the coefficient of that middle term, and C is the constant term. So we want factors of AC, namely 4 times negative 15 is negative 60. that add up to b. So I'm like, okay, what are factors of negative 60 that add up to negative 4? I believe there's a 10 and a 6, but the larger factor should be negative. So let's check it. Product of negative 10 and 6 is negative 60. Sum of negative 10 and 6 is negative 4. We checked the x game, so that means that we're good to go. Let's go ahead, split the middle term. Okay, the variable part of the middle term is u, so we're going to replace it with negative 10u and positive 6u. So let's do this. So remember, the gist of the AC method is to split the middle term, so you can have 4 terms and then factor by grouping. So we have 4u squared. We split the middle term and replace it with negative 10u and then positive 6u, and then we bring down the rest of the problem. Now that we have 4 terms, that's a u, which kind of looks like a 100, sorry. Okay. So now that we have 4 terms, let's factor by grouping. Let's group the first 2, group the last 2, and then take it from there. When we keep our cool, the first group has a common factor of 2u. And let's show the reader what we're left with when we factored from the group. First term over common factor will leave us with 2u. Second term over common factor will leave us with negative 5. So one group down, one more to go. For the second group, 6u and 15 have a common factor of 3. So let's go ahead and factor from the group. First term over common factor will leave us with 2u. Second term over common factor will leave us with negative 5. Okay, and I'm crying, but it's like happy tears. I'm crying because the binomial factors match. Okay, well, as expected, because we checked the x game. What if they don't match? Check it out. When you use the AC method and you split the middle term, the binomial factors have to match. If they don't, then your x game was wrong, but we would have realized if it's wrong if we checked it from the start. Okay, so let's do this. Let's go ahead, factor out the common binomial of 2u minus 5. And then we'll show the reader what we're left with when we factor it from the expression. First product over common factor, the 2u minus 5's cancel, and that will leave us with 2u. Okay. Second product over common factor, the 2u minus 5's cancel, and that will leave us with plus 3. Can we factor our new trinomial further? 2u and 5, nothing in common. 2u and 3, nothing in common aside from 1, so we're good. I am very tempted to box this, but check it out. Our original expression had the variable, didn't have the variable u. It had the variable m. So if we have variable terms left, they have to be in terms of m. So what are we going to do? We're going to substitute back the expression for u. Okay, so let me just put sub u equals m minus 5. Again, I am speaking to myself, okay? So wherever we see the variable u, hopefully this doesn't smear, okay? Wherever we see the variable u, we're going to substitute it back with the expression of m minus 5, okay? So we have, let me put open parentheses, 2 times u, which is m minus 5, but we're going to have to wrap it up. Minus 5, close this grouping symbol, open grouping symbol. I need my other finger, my real finger. 2 times u, which is m minus 5, which we're going to have to wrap it up, plus 3, and close that grouping symbol. Remember to pause and rewind as many times needed. Okay, so let's do this. Let's clean up each set of grouping symbol. So from the first set of grouping symbol, we look at the inside. Let's go ahead and distribute that too. So again, whenever we have more than one grouping symbol, you look at their innermost set. M and 5 are non-like terms, so this is why we distribute the 2. When we do, that will give us 2 times m is 2m. 2 times negative 5 is negative 10. We bring down the rest of that grouping symbol. So let's go ahead and start to clean up the next set of grouping symbols and same speech. Grouping symbol nested inside another grouping symbol. You look at the innermost set. There's nothing to simplify, so let's go ahead and clear it by distributing this too. 2 times m will leave us with 2m. 2 times negative 5 will leave us with negative 10. Did we do this right? I think so, yeah. Bring down the rest of the problem. Are we done? No. Why not? Because you can still simplify these expressions, okay? When we combine like terms, negative 10 minus 5 will give us negative 15. When we combine like terms, negative 10 plus 3, where am I, is negative 7. Okay, on the test, I really don't care how you do it, okay? You can do what you're trained to do, okay? Which is like simplify, I can say, but let me say a little bit different. You can do what you're trained to do, which is expand all factors and then like do what you gotta do. But the reason why I don't recommend that route, because I said it earlier, but I'll say it again. If you make an arithmetic mistake, that's it. You're never gonna get a trinomial that's factorable, and it will take you a while to realize that it's not factorable, and there goes your score. Okay, I myself prefer the substitution because it minimized the technical difficulties with my arithmetic. But either way, we get the same answer. It's a coincidence that the binomials are in the same order. It's not always the case. Cool. So I said that we're going to do 2 problems. Let's go ahead and do our second and final problem, and then we're out. I know, I can't believe it either, just 2. So we have 14 times the square of 4x minus 5 minus 23 times 4x minus 5 plus 3. Fantastic. Okay, so let's go ahead and do this. So where am I? Okay, so you have 2 ways to go about it. I'm not going to show a worked out solution. Option 1, expand all factors. In English, distribute everything. Option 2, take advantage that you have a binomial recycled and use substitution. Okay, that's the strategy that we're going to use together. Why? If you're a fan of like just multiplying everything, cool, but I know that you can do this on your own. The substitution thing, this is the first time like that we're doing it together. Okay, so yeah. Okay, so again, expand all factors or do by substitution. So let's do this. So we're gonna say, let some variable represent that binomial that we see recycled, which is 4x minus 5. What variable am I going to use? Are you a mind reader? Oh, that kind of scares me. Okay, you. So let's replace all these binomials of 4x minus 5 with u. Okay, so we have a 4x minus 5, which we're swapping out for u. What are we doing to that u? Well, looks like that u is being squared and then being multiplied by 14. Okay, we have another binomial of 4x minus 5, which we're going to swap out for u. We are going to multiply it by 23 and then subtract it from the first part of this puzzle and then bring down the plus 3. Okay, this is like too much space for me, so let me go ahead and bring them together. Alright, so let's go ahead and do this. So it's like, okay, we got a trinomial. A prerequisite step, watch out for common factors. Unfortunately, these terms don't have any factors in common other than 1. Trinomial, since the leading coefficient is not 1, then we're going to go ahead and use the AC method. Okay, so AC method, we want factors of AC that add up to B. So factors of A, B, C. Factors of A times C that add up to B. Product of A and C, namely 14 and 3, will give us 42. Value of B is negative 23. So then I'm like, okay, what works? Like 42, 6 and 7, but that doesn't work. To tell you the truth, I cannot think of another factor pair right away. 6 and 7 is the only factor pair that comes to mind because we learned that like in preschool. Well, I lied, probably like 4th grade. Okay, so I'm going to go ahead and do a factor table. Okay, so we have 42 and we have, where am I, 1 and 42. Product is positive, sum is negative, so both factors would have to be negative. Product is 42, sum is not negative 23. 2 is a factor, will be 2 and 2, 1. And look at that, sum is negative 23. Again, if you have access to a calculator, go ahead, punch in the numbers, and you can do any X game under a minute. I can guarantee, or almost guarantee. Okay, let's split the sides. So the side numbers are -2 and -21. So when we split the middle term, we will replace it with -2u and -21u. Remember to put the variable part of the middle term, because we're only splitting the middle term. We're not splitting the constant term or the first term. So we have 14u squared minus 2u minus 21u minus 2u minus 21u, and then we bring down the rest of the problem. Cool. So again, AC method, how are we going to handle it? We're going to split the middle term and then factor by grouping. When we look at the first group, 14u squared and 2u have a common factor of 2u, and that will leave us with first term over common factor gives us 7u. Second term over common factor will leave us with -1. So one group down, sorry I forgot, and one group to go. Let's look at the second group. 21u and 3 have a common factor of 3, but I know you love yourself, so we're going to factor out a -3. Why? Because we want to make sure we start on a positive note. That's the only way that things are going to match, if they're supposed to match. Who cares if the rest are negative? Okay, so let's do this. First term over common factor will give us 7u. Second term over common factor will leave us with -1. So again, it's not a surprise that the binomial factors match. They need to match, and if they don't, then our X game was incorrect. So let's do this. When we factor out that common binomial, we have 7u minus 1. Let's show the world what we're left with. First product divided by GCF, the binomials cancel out, and that will leave us with 2u. Second product divided by GCF, the binomials cancel out, and that will leave us with -3. Cool. So we have factored. Cool. And I'm very tempted to box my answer, but again, the original expression did not have a variable u. So if we're going to have a variable left, it has to be the variable x. So let's go ahead, substitute back our expression for u. So we're going to say sub u equals 4x minus 5. So if you have a u, we got to swap you back for the binomial. Okay, so we have 7 times u, which is 4x minus 5, minus 1. Let's go ahead, wrap that up in parentheses or brackets, whatever you see fit, times 2 times expression for u, which is 4x minus 5, minus 3, and we bring down, the close grouping symbol. Okay guys, so let's go ahead, clean this up so we can leave. When we distribute, product of 7 and 4x is 28x. Product of 7 and -5 is -35, and then we bring down the rest of the problem. Okay, let's knock out the next set of grouping symbol. Product of 2 and 4x is 8x. Product of 2 and -5 is -10, and we bring down the rest of the problem. Oh, I can see like the end of this video. Cool. So let's go ahead, continue to simplify. -35 minus 1 is -36. 8x, -10 minus 3 is -13. Cool. I'm crying because we did it. So the directions read factor completely. So factor, what does that mean? That is code for write me as a multiplication problem. We do have a multiplication problem, but I want to know, did we factor all the way? Maybe. So I'm cool with the 8x minus 13. Why? Because 8x and 13 don't have any factors in common other than 1. Okay? But I'm not so cool with the 28x and the 36. Why not? Well, that's because those terms have a common factor. I'm not quite sure what the GCF is. So I know there's a 4. If it was something higher, then we'll factor it. Okay? First term over common factor, that will give us, where am I? 7x. Second term over common factor, that will leave us with -9. So when you check your answer in the back of the book, you should have 3 factors. One of them should be a 4, another one should be a binomial of 7x minus 9, and another one should be a binomial of 8x minus 13. The order of these 3 binomials does not matter, but for aesthetic reasons, it would be nice if we had the 4 first, and then the other binomials, who cares, because we cannot read each other's minds. Okay guys, so I think we're good. Gracias. That means thanks.